Parallel tasks. A task is a unit of work within a process. Depending on the coding style, a task may be performed by a process, a thread, or the use of an accelerator. So in practice, a task will be a set of statements that has to be executed, and the execution is performed by a piece of the runtime system. Let's look at an example. Here I have a process with one thread, and this thread is executing one task. This task itself is generating a new task to be performed. This task is put in a task queue while waiting to be executed by process 2. Process 2 has two threads, one for each queue, and when the thread is done with a task, it will pick up a task in the queue and execute it. And everything is done when the queues are empty and there is no random task anymore. So the task characteristics. First one is how the task access data. The dependencies between the tasks. So does a task has to wait for another one before it can start. The amount of work of a task, that is called its granularity. Does a task need some resources to execute? For instance, if it's a task that executes on an accelerator, you will need the accelerator to be free. Is a task repeated many times? As a task a priority of execution? And you can consider two kinds of creation time, static and dynamic. In the static case, you know exactly what to do before at compile time. So before you execute the code, you know what the tasks are. And dynamic, the tasks are creating at execution time, during the execution. And in that case, the number may vary as the program, the application is executed. The tasks synchronize themselves in mainly two cases. A task is providing some data to another one, or the task accesses the same memory block, and one of the tasks is modifying the value of this memory block. If all the tasks only read the data, there is no constraints, everybody can read in parallel. But if one of the tasks is modifying the data, then you must ensure that this modification is either seen from the other ones, and also you don't want to have concurrent operation like two writes or one write and a read on the same data at the same time. So there would be no guarantee of correct execution in that case. Let's look at how the mutual execution can be implemented using pthreads. If you have pthread, you create a lock, and when you want to create a critical section, that is a mutually exclusion zone, you will call on this lock the mutex lock. If somebody is already executing this code, it will wait here for the other one, for the one that is already executing the rail, to unlock the lock. And this mechanism guarantees that only one task will execute this section of the code at a time. Sometimes you don't want to be block on lock, so you can use try lock, and it will tell the task, the running task, if the critical section can be entered in or not. So on Google Code, I've put an example called task pthreads that you can download with the svn command. And what it does is multiplying a set of matrices by a constant. So look at how these tasks are defined and implemented with pthreads. And what I'm asking you is to modify this code so you have a counter that is in a critical section and that counts the number of elements of the matrices that are bigger than 100 after the multiplications. That is, in the task you have a multiplication of the matrices. So once this is done, you compute the number of elements that are bigger than 100. And I want you to look at the effect on the execution time. Okay. And start with a small matrices and a small number of tasks, and increase the size of the matrices and the size of the task, and see what happens on the execution time. So does that scale or not? And then look at for faster ways to do this. Two references you already know, and see you in court.